Well, you know, it's no one person's project. The community came together, especially after Hurricane Ivan, and we ended up with a state-of-the-art facility. This facility is designed to last us for the next 20, 30 years, so it's really a big step forward for the Emerald Coast Utility Authority and for the county as a whole.
And we're standing on the second level of the new administrative building at the Central Water Reclamation Facility for the Emerald Coast Utility Authority. And what you're seeing behind me is the results of 2 years of work and the new wastewater treatment plant. And as you look down through the facility, you can see the beginning of the wastewater treatment process, and it's called the biologic nutrient reduction, the B&R basin. And that's where the bacteria begins the digestion of the sludge. And from here, we're going to move over to the beginning of the process where the wastewater enters the facility. It's called the headworks. We're right here on top of the headworks. This is the actual end of the pipeline. The roughly 24 miles of underground pipe from downtown actually end up right here. So the discharge of the pipe comes out right here underneath this covered area, and it's covered to minimize on odors. It flows right through these two screens, which remove all debris in the sewage stream. And then it continues on into the process where it goes through what's called grit classifiers and removes all the grit from the system, which would be sand and other debris, rocks that the screens wouldn't remove. And then outside the other end just basically comes the dissolved waste and primarily water going into the plant. Again, this is the side view now of the major equipment that we relocated from Main Street. They were purchased 6 years ago in order to help remove all of the grit and debris that's in the wastewater stream that we had at Main Street that was actually causing the plant at Main Street to fail early. And we've gone ahead and relocated them in a cost savings effort not to reuse the equipment. And that's the advantage of buying stainless steel equipment. It basically can last for the full lifetime of this facility, which will be more than 50 years. So reusing the equipment was a huge cost savings, and here it is sitting right here.
Right now we're standing over the second stage. This is a 5-stage biological nutrient removal facility. In other words, we save chemical costs by letting the bugs do the work for us. The first stage is right over to the left there, and that stage is an anaerobic stage. This is where denitrification occurs. The organisms basically attack the nitrate in order to get oxygen. When they do, they release nitrogen gas, and that gets rid of nitrate, which is one of the nutrients we're really going after. This stage here is the first stage anoxic zone. At this point, you know, the process has got a little bit of oxygen in it, but it's not truly aerated. And again, here we're continuing our nutrient removal. Well, we're looking at the tail end of the process. We've been talking about the biological nutrient removal portion of the process. But what happens down here is that we've got to separate the solids from the water. We're going to end up with a very clear liquid, a water that's better than the water that the people in New Orleans drink. But we're going to do that by separating the biological solids in these units that are called clarifiers. You see we have 3 clarifiers on line, and you can see the liquid level. If you look at the clarifier on the left, you see the equipment inside it that accomplishes what we're trying to do. There's a rake mechanism in the bottom that moves the solids to the center. And if you see those green pumps in the distance, they take those solids and recycle the solids back to the head of the process. Obviously, after a while, we grow more solids than we need. Immediately behind those green pumps, there's some brown pumps. Those pumps move excess solids, waste solids, to the building in the far right over there. That's where we dewater the solids, dry them, and we make a product that's an excellent soil amendment.
What you see here, this is the Huber disc filters, and we have 7 of them to handle the average daily flow. Basically, these are 10-micron filters, and they're the second to last step in the process. They remove any suspended dissolved solids in the water, and the waste stream is recirculated back to the head of the plant, and the clean water goes to the next step in the process, which prior to final disposal is the chlorination process. And as you just saw, we just walked through past the chlorination basin, the final step in the process where the water is completely chlorinated and treated to remove any remaining bacteria or anything in the water. After this step, the water flows over to the pump station, where it's then fed to Gulf Power, and that's basically the whole discharge of the process and the plant. It's a closed loop system. There's no discharge to the environment from this. All right, where we are now is we are inside the biosolids building. This is a separate step in the process that's used to process the sludge that comes in off the wastewater treatment plant. And the first step, as the sludge is pulled in off of the holding tanks outside, that comes inside, it's mixed in this tank here with the polymer agent to thicken the sludge, and then it's processed through this unit here where it's dewatered and eventually comes out the other end as a cake-like substance. After it goes through the dewatering press, it drops out in almost a silly putty-like consistency of about 16 to 18% cake. And you can see the sludge dropping off of there in a processed component. The sludge is pretty much inert at this point and not really hazardous in any way.